A warm welcome, all of you, to this new episode of the Hygienic Design Innovators, in which we interview product development engineers about their journey towards a new product that has been EHEC certified ultimately. And today we are joined from Sweden by Per Ström and Magnus Gullberg. They are part of a team that developed a new hygienic design tubular heat exchanger for their company, our EHEC company member, Tetra Pak. Gentlemen, great to have you with us today. Can you please first show us the component? We're very curious.
Yeah, so what you see here is a model of a Tetra Pak tubular heat exchanger. It has a principle as a shell and a tube heat exchanger. So here we have the outer shell that keeps the media inside. And here in the cutoff, you can see the tubes.
Can you just tell us a bit about the functionality of your product?
So what we see here is the inner pipes, which has the product inside it. And then we have what we call a shell connection, which connects the shell and over to the next tubular heat exchanger module. And that is how we build it in a modular way.
Magnus, what are in general the challenges related to designing this type of component in an hygienic way?
One big challenge working with heat exchanger that heats up and cools down product is that you will have thermal expansion and thermal stress inside the component. And this we avoid by having a floating protection system so the components can move individually. And by that we reduce the risk of cracks of the different components.
Would you do me a favor and show our viewers the backside of that component, the inlet of the tubes that will contain the product itself, and maybe also tell us a bit about the sealing technology that you apply to prevent leakage and crevices.
Here you can see it's a multi-tube. In this case, it has 7 inner tubes where the product flows. And one of the things that we recently has developed is a crevice-free product path here with a seal ring.
Can you tell us why you put extra emphasis on developing a crevice-free connection system here?
We have worked a lot with creating a crevice-free path for the product, and also that the crevice it's free from crevice not only in one temperature and one pressure, but in a wide range of pressures and temperatures.
Per, you mentioned the common practice to combine these tubular heat exchangers. What about the connections to do that? Those have to be crevice-free as well, don't they?
Absolutely. And then we have a double shell connection, called shell interconnection, which is completely crevice-free as well.
What role did the EHEC guideline documents play in the development process of this new product of yours? Did you apply them? Did you look into them before you started designing the product, for example?
We didn't thought that we could have an EHEC certification of a tubular heat exchanger. We were perhaps a little bit stuck in the thinking from 3A that you must have a specific standard for that component to be certified, and there was no specific for the tubular heat exchanger. So for many years we actually thought that it was not possible to get the certification. And at that time we just used the guidelines to, you can say, seek clarity or seek alternative ideas or actually seek proof that we were doing it in the right way. But then we reached out to EHEC and asked if it was possible to get a certification of a tubular heat exchanger. And then they said, yes, it is possible. And then that journey started. But we started to work with the guidelines many years before.
You can use that information in the forefront of the development process in order to increase the possibility to have your component EHEC certified in one go. Is that a correct assertion, or am I mistaken here?
Actually, it's interesting that you say it, because we thought in an opposite way. We thought that the institute was very efficient in what they were doing. So I think we did at least one extra test at the institute, just because we didn't want to do the test at our own.
what other aspects do you take into consideration when designing such a new product? Maybe related to the actual use, the practical use of your clients in the food industry?
Sometimes you have to think in a different way, and that we did when we worked with the insulation solution, because it's not the traditional insulation where you put a thick insulation layer around individual tubes, because that we have a really big challenge to be able to accept ourselves, because if there will be some kind of leakage, it will be impossible to see. And even if you only think there is leakage, you cannot check it either, so you will be unsecure. So therefore we developed a different system where we only have a very thin insulation material, and the main purpose is to stop the airflow. So that is what we do. So
we also work in several layers,
yeah,
making sure that the hot air stays where it is best.
Yeah. So if you get a leakage or you suspect you have a leakage, you can more or less just open up by lifting the outer insulation and perhaps also the inner one, and then you can check in to see, and by that feeling more secure that there is no leakage, or actually there can be a leakage.
And everything is open downwards.
Yeah.
So if there is a leakage, there will be also dripping down.
A good design is also an effective design. And we haven't actually talked about maybe the most important aspect of any heat exchanger, which is the energy efficiency. So the efficiency in which the heat is transferred from one medium to the other. How did you approach this? And did you also make hygienic design related design decisions that would improve this energy efficiency of your product?
Yeah, of course. So we can say here in the beginning, the tubes are smooth, but a little further in that we can see here in this cut up model that we also put on a corrugation pattern to increase the turbulence in the product flow. And by that, we also increase the heat transfer efficiency.
You've been working for Tetra Pak for quite a while, but there's also young people coming in from the universities. How do you make sure at Tetra Pak that they also have this hygienic design knowledge and that they know how to apply it in product development?
I can answer for myself. And since people have been working in the organization for quite a long time, I see it's quite simple, because you transfer the knowledge from colleague to colleague. And when you start working, you realize that it's very natural to think about the hygienic design. But I know that there is also trainings within Tetra Pak about hygienic design. And we have hygienic design experts as Stefan Åkesson, for example, that can help out. But the best way to learn hygienic design is to do a EH certification process, I would say.
Yes. Thank you very much, gentlemen. Per Ström and Magnus Gullberg. Have a great day. And
Same to you.
See you in the future, hopefully.
Yeah.
Yeah. Bye-bye.
Bye-bye.
Bye-bye.